everybody to please, I would advise everybody to please mute so we can have the best interactions. So good afternoon, everybody. My name is Dr. Zainab Yunusa Kaltungo. I'm the coordinator of this Biomedicine and HealthCare Journal Club. And I want to say a very special thank you to everybody for being here, but even more special thank you to Mr. Linus, who is replacing our very familiar data guru and Mr. Felix Emeka Enyama. He's assured me that Mr. Linus is like a twin brother. So expectations are very high, but I have no doubt that you feel the shoes, the really huge shoes. Okay, so without further ado, so we're going to go straight. I'm going to allow Mr. Linus to do a little introduction of himself, and then he'll go straight into the stats. And then we can do just a little clip of 1 minute from the last session, and then we can do a Q&A. So, Mr. Linus, thank you very much. You're welcome. If you want me to let you share screen, please let me know, and then we'll do that.
Thank you, Dr. Zainab, for the generous words. I'm not here to fill Felix's place, but we grow every day. My name is Linus Osai Chidi. I am an epidemiologist and data scientist. I've been in research and data science for a good number of years. I would say at least 8 years now. And Felix and I have worked together on various projects, and I'm honored to be here amongst your midst to do this evening. That's just a brief introduction about me. I'll let Dr. Zainab continue with the next item, which is to share what was revised or the review in the last session, and then we can take it up from there. I'll move on to Q&A. I hope that's okay.
Okay. I thought you go straight into the review. Sorry, I should have cleared this with you. My fault. I take responsibility. But do you want me to share? Do you want to share screen? Did you press slides?
I didn't prepare any slides, but I
made
some
comments. You don't have to.
But I made some comments on the paper. I hope I could share my screen. I like to share
that's fantastic. Okay, good. All right. So unfortunately, I don't know what's happening. I'm going to have to make you host so you can share screen, but try. If it doesn't work, then I'll have to make you host, give you host rights.
All right.
So try to share screen. If it doesn't allow you, then I'll have to make you host.
Okay. It's telling me host disabled participant screen sharing, so I can't share my screen right now.
Okay. Okay. Can you try again now, please?
All right. Yes, it's coming up.
Fantastic.
All right. Please confirm when you can see my screen.
Clearly, I can see your screen. If you could just go to full screen so we can see it's minimized.
Okay, Karen, just let me try something else again. All right, is this better?
Okay, we can see, but you know, we always want more. We can see, so go ahead. Please.
Can you see the paper?
Yes, clear. It's better. You've blown it up now. Yes, we can see now. Yeah, please go ahead.
All right. Good evening, everyone. It's a great opportunity to be here speaking to everyone on this call. I'm sure we all have a variety of experiences, clinical research and statistical and otherwise. So I'll be giving my own, should I say, opinions on the matter on this particular article, specifically the statistical analysis that was done. Starting with the title, Influence of Systolic Blood Pressure on Outcomes in Nigerians with Peripartum Cardiomyopathy. I will just quickly dive to the aims of their paper. I wouldn't want to dwell on the introduction. And the aim of the paper is the authors indicated that the present study was aimed at assessing clinical features and outcomes of PPCM patients grouped according to their baseline systolic blood pressure. This is systolic blood pressure. Okay, and from their statistical analysis or from their methodology, the areas that I highlighted and I would like to discuss with us here. First was the categorization of the systolic blood pressure into 7 groups. And the indicated analysis as described by the authors include carrying out what we call a skewness test for the continuous variables. And they use proportions, medians, and means to present their data sets. They also indicated that chi-square and Fisher-Exact and student t-test and the Mann-Whitney U-test were used to compare continuous and categorical variables. And they indicated that the association between all-cause mortality and BP categories and other variables of interest were determined using Cox regression models. Using the entry method with proportional hazards confirmed by visual inspection. There's a little bit of ambiguity there, but I'll come to that later. And they also indicated that regression models were developed to explore the relationship between LV functional recovery and systolic blood pressure and its groupings to derive adjusted odds ratio. And the two-sided p-value was used as the minimum level of statistical significance. Okay, quickly, I would like to show what their findings were. And this is their first table. This is their first table, and their first table is showing the clinical characteristics, echocardiographic features, and the outcomes of the patients. Here we see a breakdown of the age, systolic blood pressure, diastolic blood pressure, other echocardiographic properties, the BMI, and the rest. And then the follow-up in months was presented in medians and interquartile range. Starting with this, I would say this is just a summary statistic that was presented, and there was the results for the skewness tests, which was indicated here, was not presented to show how skewed the variables that were collected are. And there was no indication of any comparative analysis done on this table. So this was just a summary statistics based on the different blood pressure groups, which were 7 groups, as you can see. People who have systolic blood pressure less than 90, people who have systolic blood pressure between 90 to 99, and then 100 to 109, and 110 to 119, and 120 to 129, and 130 to 139, and above 140. However, my concerns with this particular table would be, first, if the authors were here, I would like to ask what the criteria for these 7 categories of blood pressure were. And if it was, if you're not speaking, please mute. Okay, so like I said earlier, that my first question will be what the criteria for the 7 categories were, and why the patients were grouped into these 7 categories for systolic blood pressure. That would be my first question, and that would be my first concern really to the authors on this particular table. My next the next question, the next figure or the next result that was shown was the mortality rate and the unrecovered rate based on the different blood pressure groups, systolic blood pressure groups that was shown. Now, this is a bar chart that shows mortality and unrecovered as highlighted with the legend here, but there was no indicator of any comparative analysis done here. And while the authors are claiming that a total of 136 patients had the frequency of RPP greater than 10,000 with significant variation between the groups, They didn't indicate what statistical test was used to derive this p-value that is highlighted here. That wasn't indicated. So we had no idea how many groups were tested and what kind of analysis was done to compare the variations in the RPP values. The authors also indicated that the highest frequency of all-cause mortality was recorded among patients with systolic blood pressure less than 90, followed by those with blood pressure between 90 to 99 millimeter mercury. But they are also showing us a p-value here, and they didn't indicate what statistical test was done. There was no table to show any statistical test that was done to generate or derive these p-values. So we are guessing in the dark here, and this can leave the whoever is reading this paper open to a lot of speculations and suggestions that the authors do not intend. Similarly, they also indicated another p-value here based on the unrecovered LV systolic function and the relationship between the SPB groups, which is the systolic blood pressure groups. And I'm assuming, my assumption would be that this was a chi-square test that was done because the SPB groups were discrete variables. However, there was still no table showing how the distribution of the LV systolic function was in the different SPP groups. And similarly, they indicated the cost proportional regression model to show that the systolic blood pressure of less than 90 millimeter mercury had an hazard ratio of 4 with a p-value of 0.006. And then the LVEF had an hazard ratio of 0.9 with a p-value of 0.003. So these were the author's findings in quotes, but my critique on this will be, first, if this was me, I would, and I had to be subjective about categorizing the blood pressure. I'll either categorize the blood pressure according to the mortality, that's those that had any form of mortality and those that had no mortality, or I categorize the blood pressure according to blood pressure control based on clinical examination, which could be based on an international standard to determine blood pressure control in people that have hypertension. That would be my first instinct. Secondly, I would say that if they intend to apply Cox regressional models, it's better to dichotomize the outcomes. There was no table showing any of the outcomes as dichotomized, and there was no figure showing that. Thirdly, I would say the skewness test that was indicated here was not shown, and hence they presented their findings using the normal distribution. My advice would be, when carrying out a cross-sectional study, a cross-sectional longitudinal study, which this seems to mirror, it's always easier to just summarize your data set using the normal distribution, because in carrying out a skewness test, it's supposed to indicate which of the variables were right skewed or left skewed, which was not done here. And then it leaves a lot of the analysis that was done to speculation. There was no, I would say there was no direct method, or there was no systematic method of analyzing these data sets. It's mostly speculative and it's mostly subjective according to the author. And this is difficult to replicate. And the essence of any scientific research is to replicate the findings as quickly as possible, as best as possible in any other scenario given. Now, they indicated using a Mann-Whitney U test. I did not see any table showing the Mann-Whitney U test comparisons. And I would have loved to see an analysis of variance comparing the different variables that were collected between the various groups, which was not done. So the test that was indicated in the statistical analysis and the outcomes are not correlating in any way, because we are not seeing any tables that represent the outcomes that were shown. And there's a lot of confusion really in this Cox proportional regression, because there was no table indicating what their findings were. And like I said earlier, it's better to dichotomize. At this point, I'm going to pause, and this is my summary of what their findings were so far. And I'd like to open the floor for questions or clarifications before we look at their conclusions.
Thank you so much. Really succinct. Thank you. But before we start Q&A, there was something you said that, that is related to and kind of agrees with what the reviewer said. So I'll just play it. So if you can just stop sharing so I can play it for the participants. So just give me a second to play this. And then maybe I should make it go back a little so that in case if you didn't hear, I don't have to go through too much trouble. Also a bit too much. Okay.
And it was not also reported. And also there was no mention of missing data.
Sorry, can you hear it? Did you hear? Did you hear that part? Did everybody hear?
Yes, I heard that.
Oh, all right, good. So he'll get to the question in like 2 seconds.
And how it was dealt with. The statistical analysis, chi-square feature exactly student tests and monitoring tests were used to compare continuous and categorical variables. However, looking at this article, the patients were grouped into 7 based on their baseline systolic profile. So student tests will have been more appropriate to compare the medians between the two groups. Okay, student t-test is actually used to compare the medians in 2 different groups. And in this case, we have 7 different groups. So analysis of variance should have been more appropriate for this study. And then if you look at the distribution of the results, is non-linear. So Mann-Whitney test may not be appropriate. Skawali test, because even the population, the sample size for individual group is not the same. You see that more than 48.9% of this patient have 110, 190. Most of the time now, the only 9 patients have blood pressure less than 90. So the distribution is very important. The Skawali test will have been more appropriate than Mann-Whitney.
All right, good. So thank you very much. What do you have to say? I think the reviewer is here. Network has not dropped him out. So Mr. Linus, what do you think? Do you agree with him?
Yes, I agree with him, especially on the part of the ANOVA. And if they indicated that they carried out a skewness test, there's an assumption that the data sets do not follow the normal distribution. Hence, the Kuskawali test was the most appropriate form of test to analyze, especially between more than 2 groups. And the authors had done 7 groups of people based on their baseline systolic blood pressures. So the Kuskawali test is the non-parametric test for the non-parametric form of an analysis of variance, which is applicable in this instance. But like I said, since we also didn't see the result of the skewness test, we cannot justify applying any of the non-parametric statistical analysis, because the results of the skewness test enable us to apply the results of the non-parametric statistical analysis. Secondly, I would also like to say, because this was a longitudinal study and there wasn't any sample size calculation based on a particular formula, it is also subject to a lot of skewness. So we expect the data sets or the variables that were collected to be skewed and not follow the normal distribution. Typically, research or any form of data collection that is carried out based on any sample size calculations tend to follow the normal distribution. And if it's I understand why they will carry out a skewness test, because that's what you typically would like to do, especially when you're carrying out a regression analysis. However, because we didn't see what the skewness test showed, I would not agree with the findings of their regression analysis.
So I'm going to give a huge pass mark. Maybe we'll give him like a very small diploma in statistics, the reviewer. Thank you so much. So now I think we can take questions and answers. So we can go into Q&A. So if you would like to ask a question, please raise your hand, and then I will ask you to unmute, and then you can ask your question. Thank you. Dr. Abakar, you're here. So if you have any questions or comments, would you like to, that's a reviewer. Okay, I don't see him anymore. I think network has dropped him out. But if anybody has a question or comment. Questions, comments, additions, subtractions. Okay, first of all, let me, I don't know if Mr. Felix told you, but most of the people on this forum are early to mid-career researchers. And I want to say that a lot of us are still at the level of statistics 101. So what I would want you to define for the house is, one, I know a lot of people have an idea what a normally distributed data set is, but you can just briefly highlight, and then you used dichotomize a lot. If you can just break it down for us whilst we're waiting for somebody who's camera shy to ask their question. Or you can put your question in the chat box and I'll read it out whilst he's answering. Thank you.
Okay, all right, thank you for that, Dr. Zainab. So the normal distribution is what we call the Gaussian distribution in statistics. There was a mathematician named Carl Gauss that derived a formula for determining how distributed, how dispersed or close a data set is. So in the normal distribution, what we are trying to determine is to determine the closeness or dispersion measurements of the data set. Because sometimes when you are sampling the respondents or the participants of a particular study, or when you're collecting your data, there may be some characteristics in the population that may be unique, especially if you are having different groups of people that you're collecting data from. So Carl Gauss created the normal distribution theorem and generated a normal distribution curve, and indicated that once you collected data or you are measuring variables and it falls into the normal distribution, which is, it has a range, there's a particular range and a mathematical formula to it. I cannot give that right. I can't remember specifics right now, but typically when we see a skewness or a kurtosis of minus 1.2 or any skewness or kurtosis less than or greater than 1.1 or 1.0, we in statistics tend to say that the data is not normally distributed. But once the skewness or kurtosis falls within a range of 0 to 1, we will say that the data is normally distributed and is not greatly dispersed. Hence, when we carry out a measure of central tendency, which is calculating the average and the standard deviation, it gives us a near accurate idea of where the center or how closely or how dispersed the sample population is. I hope that answers your question, Dr. Zainab.
Yeah, yes, it does. But I know for those who are core clinicians here, they'll be waiting to hear you mention the bell curve. That's what they used to teach us in medical school. And I was waiting to hear that. I didn't hear it. I know you're talking about the same thing. So please link it up for us.
Okay, so it's simple. The normal distribution curve is the bell curve. We call it the bell curve because that's the shape that the normal distribution takes. I apologize for using too many statistical terms. So what I'll try to do is I'll try to link it a lot to some layman languages so that all of us on the call can understand. So please permit me to say that in short form, the normal distribution is the bell curve. And The skewed distribution is anything that does not look like the bell curve, either left or right. It is, once it's left or right skewed, you apply a non-parametric test, but once it's normally distributed, then it's the bell curve. All right.
Thank you.
Your,
Thank you so much.
Your second question on dichotomy.
Yes.
So, so dichotomizing, like I said, in this paper, they categorize the people, the respondents, according to systolic blood pressure in 7 groups. I was saying typically, if it were me and I want to calculate a Cox proportionality hazard, which what they intended to do there was to determine the hazard risk of a mortality, it is better you create 2 groups instead of more than 2 groups, which they did in this instance. So dichotomizing means creating 2 groups, and you create the 2 groups based on specific criteria, either based on some kind of characteristics in the study population. So for instance, if I'm looking at this paper, I would most likely dichotomize them. I'll most likely dichotomize the systolic blood pressure based on people, based on mortality and no mortality, to help me create the Cox proportionality hazard. Or I dichotomize based on, since every one of us here have some form of clinical experience, I dichotomize based on blood pressure control, based on the clinical definition of blood pressure control, which could be above 140 or below 140, to determine those that have controlled blood pressure and those that have uncontrolled blood pressure. Or I could even dichotomize based on the clinical definition of hypertension and no hypertension. So that's what dichotomy means. Dichotomy means creating 2 groups, creating 2 groups from your data set based on particular characteristics. So I see, does that answer your question, Dr. Zena? Because I see one other question in the chat box. Are you with us, Dr. Zena? Dr. Chidi, okay. Okay, please go ahead.
Thank you. I was trying to switch to what I thought was a more reliable network. But okay. So before we take Dr. Chidi, there was a question in the chat box before Dr. Chidi raised his hand. And sorry, just one correction. This group is actually biomedicine and healthcare. So we have pharmacists, we have lab scientists, we have nurses. So it's a mix, it's not just clinicians.
All right.
Right here. Thank you.
Apologies for the mix-up.
So no, I should have clarified. Thank you.
Okay.
So the question from Usman Suleiman said, what test can be used to check for normality? And then he asked another follow-up questions. Are there a combination of tests? I think he means that can be used to check for normality. All
right. So statistically, there's just one test, and it's what we call the skewness or kurtosis test. And now, thank God for technology. These days, you can just go to using SPSS specifically or different statistical packages. You go and create a summary statistics. And the summary statistics, you select the options for kurtosis and skewness. That is what tells you if your data is normally distributed or not. And like I said earlier, when you have a kurtosis or skewness between 0 and 1, then your data is normally distributed. However, when you have a kurtosis or skewness value that is above 1 or above -1, then you now have what we call a skewed distribution. I hope that answers your question.
If you're not happy, you can unmute or you can raise your hand and we'll let you ask again. So now we can take Chidi. Chidi, a brief introduction, what's your specialty, and then ask your question. Thank you.
Okay, thank you. I'm a pathologist with the University of Nigeria Teaching Hospital. Thank you. So I wanted to be cleared on what you mean by the distributions, non-parametric and parametric.
Okay. All right. So based on what I've defined as the normal distribution, when you have a normally distributed data.
Okay.
Okay, I think I muted you. Sorry, Mr. Linus, I was going to mute Chidich. There was interference from his end and I can't find you anymore. Just a second, please. Or did the network drop him out? Okay, no, you're not muted. Please go ahead. Yes. I think it's the network. Go ahead.
It's still on the call. So based on what I defined earlier as normally distributed data or skewed data, for normally distributed data, we apply what we call the parametric tests of analysis. And examples of the parametric test of analysis is the analysis of variance or the independent t-tests. And for the skewed data that do not follow the normal distributed bell curve, we apply what we call the non-parametric tests of analysis. And those non-parametric statistical tests include the Kruskal-Wallis, because those tests account for the outliers and sometimes most likely the confounding variables that made the data set to be skewed instead of normally distributed. I hope that answers your question, Mr. Chidi.
Not really quite. You're trying to say that that the normal distribution is the only parametric distribution we have, is that?
So I think there's a mix-up. There's a mix-up. Yeah.
There's a mix-up, yes.
Yeah. So
go ahead, please.
Normal distribution is a concept on its own. Parametric and non-parametric tests are not distributions. Those are tests of significance, or those are statistical tests of significance. The normal distribution is the basis to apply either a parametric or non-parametric test of significance.
Are you clear? Judy, are you clear?
No, I'm not clear.
Okay.
No,
let me put it this way. Let me put it this way.
Let him.
If a normally distributed.
Because I was thinking, sorry, excuse me. I was thinking your test of significance is a different thing altogether from, the type of testing for the type of distribution exhibited by your samples. That was the understanding I had.
Yes. The test of significance is the analytical or inferential test, and examples are the analysis of variance, the independent t-test, the paired t-test, the chi-square analysis, the Kruskal-Wallis test. All of those are tests of significance. All tests of significance are categorized into two groups, the parametric and the non-parametric. All right. Now, these tests of significance are then applied based on if the data set is normally distributed or not normally distributed. Now,
that is for the, sorry, excuse me, that is for the parametric.
Okay.
Yeah, because the parametric is supposed to be analyzing the parameters are supposed to describe the curves. That's what I understand.
I'm sorry, there's a mix-up there. There's a mix-up there. Okay, so when you carry out...
for your bell curve, you have certain parameters that characterize it.
Yes.
So what exactly is the non-parametric thing?
Okay. So for the bell curve, you apply the parametric tests. For the skewed curve that is not a bell curve, you apply a non-parametric test. Now, let me clarify. First, you carry out the test of normality to determine if it's a bell curve or not. All right? When it's a bell curve, you use a parametric test to carry out your inferential statistics. When it is not a bell curve, you use the non-parametric test. So the non-parametric tests are opposites or synonyms or siblings of the parametric test, but they are only applied when your distribution is not the bell curve.
Okay. Thank you. Thank you.
All right.
Sorry, I'm still muted. Any other questions? If there are none, then maybe we can further break it down a little more for him. Any more questions? Because he doesn't sound like he's very happy. Okay, there's a hand up. Yes, Dr. Dorothy, please unmute and speak.
Okay. Good evening, all, and I think you can see we have different classes, people with experience in statistics in the forum, and I can see even the last speaker still looking a little bit. Sorry if I use the word a bit confused or not clear. Asking, is it possible to probably have classes, step-by-step classes for this group to put us through basics of, statistics that we may need in the course of our research work?
Okay. I don't want you putting Mr. Linus on the spot because he's just here to rescue us. I would suggest I will try and post the link in the chat before we finish. I'll suggest you sign up with Author Aid, because this journal club is an Author Aid platform. And if you can just go to the videos, we've had several sessions. The person who was supposed to be here for the statistics session, Mr. Felix Emeka, has taken us through. We've been on this journal club now for about 5 years. So we've done the basic of statistics, and we have all the recorded videos on the Author Aid YouTube page. And now there's the Nigeria Research Hub. And on the Nigeria Research Hub, we also have a YouTube page, and we've done a lot of statistics too. So it would be nice if you can check them out. Then in addition, if you've gone through them and there's still something specific that you'd like to know, then let us know. That's why we're here. We're all here to learn. But I like that question. Thank you. And then, as you said, there are many people on the group who are at different levels, and we have a lot of gurus too. And I'm sure a lot of them will be very happy to give us a talk. So thank you, thank you, thank you. So any more questions? Whilst I try to fish out the link and fish out the link and post in the chat box for those of you who are not signed up with Author Aid. And all Author Aid resources, webinars are entirely free. So please sign up and get the most benefits that you can from there. We also have a mentoring platform too, in case if you're interested in mentoring. All right, so let's take another question. If there are any more questions, comments, whilst I'm fishing for the links. Questions, comments?
Okay, Dr. Zainab, while we're waiting for that, I would like to just touch on that earlier question by Chidi. And
yes,
the thing is, sometimes we can get a lot of statistical terms confused and intertwined. I like to go with the simple approach. It's always been the best way to try and do this. And the simple approach is this. The first thing you do is you subject your data set to a normality test. And when you subject the data set to a normality test, it tells you if the data is normally distributed or not normally distributed. Now, the normal distribution is the bell curve, and the skewed distribution is the one that is not a bell curve. In that instance, when you want to carry out a statistical test of inference, you choose between two types of tests. The parametric type, which is applied for the normally distributed data, or the non-parametric type of tests, which is applied for the skewed distribution of the data. So I think maybe a lot of people tend to confuse the characteristic of the variable or the data set as a parametric or non-parametric data set. That's where the confusion comes in. So the data set could either be normally distributed or not normally distributed. I like to keep it at that. And then when it is normally distributed, you apply the parametric test of analysis. But when it is not normally distributed, you apply the non-parametric test of analysis. I hope this clears it up a bit.
So, sorry, I have a different understanding. Maybe you go back and clarify. From what you're trying to say, you're saying that once it's not normally distributed, I mean the sample, base, then it's non-parametric. I think that's what you're trying to say.
Okay.
But
let me agree with you. Okay, but what's your understanding of this so that I know where to come in?
I'm actually seeking clarification.
Yeah.
To understand what you mean by non-parametric. I think we can, take it on from there.
Okay.
What exactly do you mean by non-parametric distribution?
Okay. There isn't a term as non-parametric distribution. Okay. There is parametric tests of inference and non-parametric tests of inference. The distribution can either be normal or skewed. I hope that is clear.
Well, that is in a situation where you can characterize the distribution with certain parameters. It's only when you can characterize them with or by certain parameters, then you start talking about whether the parameters, the characteristic parameters, give you a normal distribution or non-normal distribution. For certain distributions, you can't really pinpoint any particular parameter for them.
Okay.
That's when you talk about.
Okay, so let me clarify. I'm going to assume that the parameters you're talking about are the mean, median, and mode of the distribution.
Yes, and the things, the way you employ them in calculating either the skewness or the kurtosis of the curve.
Okay.
Because the parameters actually characterize the shape of the curve.
Okay. All right. So I now understand where the confusion is coming from. Okay. So for the normally distributed data sets, the parameters for the normally distributed data sets, which is the most common parameter or the most common feature of a normally distributed data set, is the fact that the mean, median, and mode are similar.
Okay.
All right. Now, for the skewed data sets, okay, for the skewed data set, there is a variance, there is a significant dispersion between the mean, median, and the mode.
Okay. So
right.
Sorry, let me interject here. So that when you now plot the graph of this distribution, you won't get that bell shape, but it's still parametric. And you have different families of these parametric distributions. No. Some are exponential, some are, but yes. Yeah, so amongst the parametric, you then have the one that is shaped like a bell. That's the normal distribution. And then if you check the parameters, if you plot in the parameters that you use, okay, let me use a different example. Your line, slope line, for instance, you have parameters for it. Either it's taken off from the origin, or it has an intercept, and then it has a slope. So it's the same thing with these parametric families. So just one of them is the normal, and you can check for it. But there are other distributions you encounter that don't have really particular parameters. If you plot the properties of the set, the sample set, you won't get a nicely disposed curve like a bell. I don't know whether I'm making sense. In that case, it will be difficult or even impossible to impute any parameters to the shape of the curve of the distribution base.
All right. So I'd like to clarify something. I guess maybe I'm assuming that the point where you're coming from is when you plot out the distribution of your data or the variable that you've collected, because of the characteristics of the data, it could either be a bell curve or not a bell curve.
Yes.
Okay,
or
fine.
In some cases, it might not even, exactly. And in some cases, you might not even get anything as neat as a bell.
Exactly. That's what I said earlier. However, please follow me while I follow your logic. When it is a bell curve, all right?
Yeah.
The kind of tests, the kind of statistical inferences you can carry out on that particular data set is what we in statistics call the parametric test of analysis. All right? Now, when it is not a bell curve, meaning it is skewed, because when it is not a bell curve, it is either skewed to the left or the right. It means that the kurtosis is not near central or the skewness is not near central.
Okay.
When that happens, you then apply the non-parametric family of statistical inference of tests.
Okay. Are you clear now, Linus? Oh, sorry, not Linus. Are you clear now, Chidi?
I get what he's trying to say, but maybe I will supply references to buttress my own argument.
All right.
Yeah, from what I can understand, he's trying to say is that the only parametric distribution where you are allowed to apply these parametric tests are for the Bell distribution or the normal curve.
Exactly.
Yeah, that's what you're trying to say. But I'm, because I did some courses on statistics. There are other tests that you can apply. Can you hear me?
Yes, I've muted the person. Go ahead.
Okay. So that the distribution of your sample doesn't have to be normal or Gaussian or bell-shaped for it to be characterized as parametric.
I think you're still mixing up the term. I think you're mixing up the terms. What he's trying to say.
Let me ask a question. Why do we apply different tests to different types of distributions?
That's what he's been trying to explain. I don't want to, he's the expert here. Don't let me answer for him. Okay. It depends on the kind of data set you have. If you have a normally distributed data set, then you use the parametric tests. And if you have one that is skewed either to the right or to the left, then you use non-parametric tests.
Okay.
Am I correct?
Yes. So Chidi, let me just let's design a scenario here. Okay. All right. I have two groups of patients. All right. And these two groups of patients, group A received treatment and group B did not receive treatment. Okay. And I want to compare their fasting blood glucose. All right. So I collect my data set from them and I subjected the fasting blood glucose that I collected to a normality test. All right.
Okay.
After subjecting it to a normality test, I find out that the distribution of the fasting blood glucose is not normal. It's not the bell curve. Okay.
Okay.
So which statistical test will I use to compare the fasting blood glucose between blood groups?
Okay, here is where my question comes in. If you check the distribution of your tests. If it's not normal or Gaussian, can you still characterize it, using certain other parameters? That's just what I want to understand.
So when you mean characterize, you do not need, okay, let me say something. If somebody gives you a car, all right?
Okay.
In statistics, you do not customize, you can't customize the car.
You define it as it is.
You just define it as is. That's what we're trying to say here, that in statistics, whatever the numbers give you is what you describe. You don't.
Yes, but you describe using the parameters, using certain parameters.
Using parameters, exactly. So for the skewed distribution, the mean, median, and mode are far apart from each other. Those are parameters that you can use to describe the data set. But
Okay.
my question to you was, if I have fasting blood glucose for two groups, and I find out that they are not normally distributed, and I want to compare the fasting blood glucose between both groups, which test will I use to compare the fasting blood glucose between both groups after finding out that the fasting blood glucose that I collected was not normally distributed? What test? I'm not describing the data set now. I'm asking, the question is, what test of significance do I use to compare the fasting blood glucose of both groups?
You see, I might not be able to give you anything specific. And that's why I'm asking. I want to be in a position where I can derive these things.
Okay, I think let me just come in here. I think we're going to arrange a special session to talk about data, what they're collecting data, subjecting the data to normality tests, the kind of what do you call it, statistical tools you can use for parametric and non-parametric data. I think it will probably sort out this issue. So be on the lookout. So Mr. Linus, if you're not on our Journal Club group, I've posted a link in the chat box for all the AuthorAid websites and to join this group. So if you're interested, please make sure you join before 7 p.m. today, because I'm going to be resetting the group link. So before we close, somebody was raising his hand, Suleiman. Sorry, I hope you're still there. I hope you didn't get tired and then leave. Suleiman, are you still there? Or do you still want to ask your question? Because I promised Mr. Linus we won't go beyond 1 hour. We've gone more than 1 hour now. Yes, Usman Suleiman, yes, please go ahead. Thank you.
I didn't want to ask a question, because of we were going back and forth. So I wanted to learn my understanding so that we won't go off the discussion. So okay. What I wanted to say was that what I understand about parametric, when they say the word parametric, it means that you have a known distribution or a pattern which your data follows. You call it parametric. When it doesn't follow any particular pattern or distribution, you say it's non-parametric. So there are several distributions that we know. The geometric distribution, the gamma distribution, uniform, there are several of which other fields apply. So what I know in the medical sciences or in the biomed, we apply more of the normal distribution. And most of the tests we use, which we call parametric, are built on this normal distribution. And that's why we just go ahead and say normal distribution. Their parameters. So that's the way I understand them. And when they don't follow this particular distribution, we say they are non-parametric. But most of these tests, the Z test, the T test, all of these tests, the ANOVA, all of them are built on this assumption of a normal distribution. And that's why many a times when people say the data is parametric, the assumption is the underlying distribution is a normal distribution. And when they don't fit into that normal distribution, we now say we take up the non-parametric tests, which they are referred to as distribution-free tests. They don't require you to have a known distribution before you apply them. And so once there's no, you don't need to know that the data follows it. But the issue they have is that they are not as powerful as those parametric tests that have a known distribution, which they assume. So for us in biomed, I understand that we use the Gaussian distribution, which most of our statistical tests are built upon. And that's why we use the word parametric. Thank you very much.
Thank you so much.
All right, thank you. I think it just says that we still have a lot of work to do on this journal club. And somebody has buttressed the suggestion that we should have a session that will tell us about collecting data, testing your data, what kind of data you have, and then the different kinds of statistical tools that we're going to be using for the different types of data, whether skewed or non-skewed data or normally distributed data. So I think it's been a very interesting session, and I would like to say a special thank you to Mr. Linus for coming in and doing a very beautiful job. Thank you so much to all the participants for making it a very interesting session. We have another session next month, that's in March. It's a psychiatry paper, but we're also going to have statistics separate. So whether you're a psychiatrist or not, try to attend because it will bring out a lot of discussion. And then we'll let you know on the group. So if you're not signed up with the Biomedicine and HealthCare Journal Club, again, link is in the chat. Try to join because I'm going to be resetting the link because we've had a problem with spammers and people posting all kinds of things because they didn't realize the importance of the group. So once again, so we'll see you again next month. Thank you very much, everybody, and have a really lovely weekend. Bye-bye.
Thank you.